Alright, so we just closed out our special right triangles unit. We're now going to start in on trig. So the first thing for you to know is that trigonometry, which is the long word for trig, means triangle measurement. It's also important for you to know that trig involves ratios, which we refer to ratios as just fractions. And these ratios or fractions compare two sides of a triangle. And then just like special right triangles, trig only works with right triangles. So before we actually get started into trig, there are some definitions that you need to know beforehand. The first one is a hypotenuse. We've already dealt with this before, and remember, this is a side across from the right angle. This also is our longest side in the triangle, so remember, those two things never go away and they don't stop just because we're moving into trig. The next one we need to know is called the opposite side. And the opposite side is the side that's across from the angle of interest. We'll talk about what the angle of interest is in just a second. The third one is called the adjacent side. And the adjacent side is the side that makes the angle of interest, but it's not the hypotenuse. So of course, two sides make that angle. If one of them is the hypotenuse, the other one is what the adjacent side is. And then your angle of interest is the angle that we're focusing on. So I'm going to say write this according to angle A, according to angle B. So it's that specific angle that we want to focus on. That's our central point. So the first thing we're going to talk about is labeling sides. All right, so your first step when labeling sides is to mark the angle of interest. Then you're going to label the hypotenuse with an H. And remember, this is across from the right angle. So across from that little box or across from where it says 90. You're then going to label the opposite side as O. And remember, this is the side across from the angle of interest. Now, you should only have one side left. There are three sides in a triangle. So you're going to label this final side as the adjacent side, or A. And like I just said, remember, this is the only side that's left. So you've already labeled the hypotenuse. You've already labeled the opposite side. That third and final is the adjacent. So you label that with the A. So here, your first example, I'm asking you to label the sides, so hypotenuse, opposite, and adjacent, in reference to angle A. So I told you how there was a specific angle, that's our angle of interest. That one here is angle A. So your first step, like I told you, is to mark the angle. So angle A is up here at the top. I'm going to mark it in red so I know that's the angle I'm talking about. I'm now going to start labeling my sides. I know the side across from the 90, so if I drew my little arrow across from the 90, I know this is the H, or the hypotenuse. So remember, your first step, mark the angle. Second step, label the hypotenuse. Your third step is to mark the opposite side. So I look at my angle of interest, I draw my arrow across, and that tells me which side is my opposite side. So I'm going to label that with an O. Now, my third or fourth step is to label the adjacent side, which is the only side left. So I already have my opposite labeled. I have my hypotenuse labeled. That means this third side is my A, or my adjacent side. So in our second example, we have the same exact picture. What's different is what I'm asking you to do here. I'm asking you to label the sides in reference to angle B. So in the first example, we talked about in reference to angle A. Here, we're talking about angle B. So my first step, as always, is I'm going to mark that angle. I have angle B marked. I'm now going to label my hypotenuse, which is across from the 90, and that's going to be my H. The next thing I'm going to do is label my opposite side, which is across from my reference angle, or the angle indicated. So this is going to be my O, or my opposite side. And that third and final side is going to be my adjacent side, or my A. Now, if you look here in both of our pictures, the hypotenuse is the same because it's across from the 90. What changes, though, is the opposite side and the adjacent side. And they changed based on the angle. So because we did angle B in the second example, that's why the opposite and adjacent sides changed. So here in this third example, we're doing the same thing. We're labeling the sides. This is the last one of this kind that we're going to do. I gave you another right triangle. It's just flipped. And I marked the angle of interest for you, which is C. So when I'm looking at this, the first thing always is to label your hypotenuse. So we look across from the 90 degree, and that tells me my hypotenuse is here. I now want to label my opposite side, so I look at the angle I'm looking at, draw my arrow across. That tells me AB is my opposite side. And that third and final side that I haven't labeled yet, that's going to be my adjacent, or my A side. So we're actually going to get into our trig ratios now. There are 3 trig ratios that we use. And we're going to talk more about what those three are, what they mean, and then we're going to start kind of practicing how to use them. The first one we use is sine. And so here I wrote sine of x, and that x in the middle, that's your angle of interest. So for today, it'll be a letter. When we start moving on, it's going to be an actual number. Tomorrow stuff, you'll see the number. And you need to know that sine, you take the opposite side. This is where we write our ratio or a fraction, and you put it over the hypotenuse. So this is our first one. You need to know that sine is equal to the opposite over the hypotenuse. Our second one is cosine of x, and remember that x is still the angle of interest. And cosine is equal to the adjacent side, so the a side, over the hypotenuse. Third and final trig ratio is tangent or tan of whatever the angle of interest is. So whatever's inside those parentheses is your angle of interest. And tangent is equal to the opposite side over the adjacent side. So these trig ratios are written with two sides. We talked about a ratio being a fraction, so you need a top and a bottom, and they have specific ones. We're going to talk more about that in just a second. These trig ratios are kind of hard in the beginning, and there's a way that we remember it by. So I'm going to go ahead and write it out first, and then I'll let you know what it stands for. The first one is SOH. The next one is CAH. And then the final one is TOA. What these stand for are the three different trig ratios. So the first one is sine. The second one is cosine. And then the third one is tangent. Now the two letters afterwards refer to those sides. They refer to those ratios. So remember I told you that sine was the opposite over the hypotenuse. Cosine was the adjacent over the hypotenuse. And then finally, tangent is your opposite over adjacent. Now we call this SOHCAHTOA because you have your SO at the front, which is your sine. The middle is your CAH, C-A-H, and the last one is TOA. So remember, sine goes with opposite and hypotenuse. Cosine is adjacent and hypotenuse, and tangent is opposite and adjacent. So we can actually use sine, cosine, and tangent to write ratios of sides. You have a few steps to follow, so we're going to go ahead and write those over here. Your first step is what we've already practiced, and you're going to label the sides. And remember, you're labeling them according to that angle of interest or the angle that we identify. Your step number 2 is you're going to remember your SOHCAHTOA. You need to make sure you're keeping that in mind always here with the trig. And you're going to identify which two sides you have. And your third and final step is to write the two sides being used as a reduced ratio. And that means that if it's a fraction, you need to see if you can reduce the fraction. If you can divide the top and bottom by the same number, then you need to do so, and then that final answer should be the reduced one. So in this example, I give you a triangle which is over to the right, and there's actually side links with this, so that's what's different here. And I'm asking you to write the reduced ratios for sine of z, cosine of z, and tangent of z. So remember, I told you in those parentheses tells you what our angle of interest is. All three of these are z, so I'm going to go ahead and mark the angle. Now I told you your first step was to label the sides. So I'm going to label my hypotenuse first. I look across from the 90-degree angle, which is right here. So that tells me that 13 is my hypotenuse. I now look across from the indicated angle. That tells me that 12 is my opposite side. And then my third and final side is whatever is left, and that tells me that 5 is my adjacent side. Now I need to remember my SOHCAHTOA. So the first one is sine, which is so S-O-H. Sine is O over H, the opposite over the hypotenuse, When I look at my triangle, my O side is 12, so that's what goes on top of my fraction, over my H side is 13, so that's what goes on the bottom of the fraction. I cannot divide 12 and 13 by the same number other than 1, so this ratio of 12 over 13 is my final answer. Sine of z in this case is 12 over 13. The next one I'm going to do is cosine of z. Cosine, remember, is the cut in the middle of the things to remember, and it's CAH. So that tells me that A is on top of my ratio and H is on my bottom. So when I look at my triangle again, my A side is 5 over my H side is 13. And finally, I have tangent of z. Tangent is TOA, which is the last part of our thing to remember. So you have O over A. When I look at my triangle, my O side is 12 over my A side is 5. We don't change this into like a proper fraction. We leave it improper. All three of these ratios, we cannot divide anything into the top and the bottom, so it stays the same. So here's another example just so we can practice. I'm asking you to find the sine of m, the cosine of m, and the tangent of m. All three have the same angle of interest, so I'm going to go ahead and mark angle m. I now need to label my sides. So I look across from the 90. That tells me that 5 is my hypotenuse, or my h. I look across from the angle indicated. That tells me that 4 is my opposite, or o. And that means 3, which is the last side left, is my adjacent, or my a. So remember, sine, that's your opposite over hypotenuse. So when I look at this triangle, my opposite side, or my O side, is 4 over my hypotenuse is 5. Cosine is adjacent over hypotenuse. So when I look here, my A, or my adjacent, is 3 over my hypotenuse, which is 5. And finally, tangent is at TOA, so it's O over A. And it's equal to the opposite side, which is 4, over the adjacent side, which is 3. When I look at these ratios, I can't divide the top and the bottom by any number but 1, so they're reduced. They stay just like this. Now, this last part is approximating values, and this is just using the calculator. So for this part, if you don't have your own calculator, you're going to want to go to Desmo's Scientific Calculator. You don't want to go to the graphing because it's not going to do what you want it to do. This is an easy way for you to just plug it in and it'll give you the answer back. So in these, I'm asking you to use your calculator to approximate the following values, and I want you to round to 3 decimal places. So the first one I want you to do is the sine of 41 degrees. Now when you plug it in your calculator, you just put sine, you put 41 in parentheses, and hit enter. When you do that, you should end up with 0.656. That's all that approximating values is. So number 2, I want you to find the cosine of 12 degrees. When you plug that in, you'll put cosine and then 12, and you should end up with 0.978. And then finally, number 3, I want you to find the tangent of 3 degrees. Again, you'll just plug in tangent and 3, and you should end up with 0.052. Remember, for these approximating ones, you'll want to use the Desmo Scientific Calculator. You can pull it up on your computer. I believe you can pull it up on your phone. So I am posting practice with this, of course. All the practice is what we did in the notes today. Make sure you get that turned in as soon as possible, and let me know if you have any questions.